Hello everybody and welcome to another ATC Maths and Science tutorial video. Today we'll be discussing the introduction and definitions to acids and bases. So the first thing we need to do is understand what an acid and what a base actually are. And we will define them according to two sets of definitions. The first one being the bronsted and lowry definition, which were two Swedish chemists who defined an acid as a proton donor. Now, in the topic acids and bases, when we speak about a proton, what we mean is the hydrogen ion. So it is a hydrogen ion donor. So a base should naturally be a proton acceptor. Right? And so that's our first set of definitions according to Bronsted and Lowry. Now, what will we be using these definitions for? Apart from being asked the question, define an acid or define a base according to Bronsted and Lowry, we actually use this particular definition to help us complete certain titration reactions and even certain hydrolysis reactions. So it's a necessary definition, though its use will be seen clearly in later topics or later concepts underneath the heading acids and bases. The second definition that we have to deal with is the definition according to Arrhenius. So according to Arrhenius, an acid undergoes hydrolysis. So hydrolysis means the addition of water to form a very special compound, the hydronium ion, or H3O+. We will be using this definition quite a lot when we get to the point where we have to deal with pH calculations. That's very necessary for pH calculations. And according to Arrhenius also, a base undergoes hydrolysis to form the hydroxide ion, OH minus. Right? So an example of this would be something for, let's look at an example of hydrolysis of an acid. So let's say we have HCl plus H2O, and this would give us, so what's going to happen here is the hydrogen ion from HCl will be donated to the base. In this case, it's going to be H2O that acts as a base. We will deal with some concepts and some terms later on where we understand what H2O is. It falls under the category of an ampholyte, which is a substance that can act as either an acid or a base. But we'll take a look at that in greater detail in future videos. So this hydrogen attaches itself to the H2O to form H3O plus, and we're left with Cl minus. So this is an example of hydrolysis of an acid. Let's see an example of hydrolysis of a base and what that looks like. So with a base, let's say we're dealing with our very famous NaOH. Now, with a base, the hydrolysis equation works a little differently. We actually place the H2O above the arrow, and our base dissociates into Na plus and OH minus. Now, why is the H2O placed above the arrow in the case of hydrolysis of a base? Well, if we had to follow the steps of the reaction where water would act as the acid and then donate itself or donate one H plus ion to the OH molecule here from the NaOH, it would result in water being on both the left and right hand side of the equation. And so we just place it above the arrow to do it simpler. You'd also notice that when I was describing this, I used the word dissociates. So this leads us to our next set of definitions, which has to do with strong and weak acids and strong and weak bases. And the words that we're going to be using there, like ionize and dissociates, where we can tell the difference between what they mean based on those examples. So we've seen so far two sets of definitions: bronsted and lowry acid and base, arrhenius acid and base definitions. We've seen some reactions illustrating this. So let's look at new definitions, which would be for a strong and weak acid or base. Now, as we should know, acids have strengths. Some acids are considered to be strong and other acids are considered to be weak. And how do we tell them apart, one from the other? Well, according to the definitions, we say that a strong acid ionizes completely, and a weak acid ionizes partially. Now, what does this mean, ionize completely and ionize partially? Well, if we look at a classic example of a strong acid, which would be nitric acid, HNO3. When we say that this ionizes completely, it means every HNO3 molecule will break down into H plus and NO3 minus. It ionizes, breaks down into its ions completely. Every single HNO3 molecule. Whereas a weak acid, only some of that acid will break down into its ions. Now, when it comes to strong and weak bases, we substitute the word ionize with the word dissociates. And we will define shortly the difference between those two words. So we say that a strong base dissociates completely. Whereas a weak base dissociates partially. Now, on the surface, ionize and dissociates, they look almost identical. They look almost like the same word, or like as if they mean the same thing when you have to look at some certain reactions involving it. But there is a difference between the two, right? The difference between them would be, well, this is the proper definitions. So dissociation is defined as the process where a molecule forms ions or charged species, right, which already exist in the compound. For example, NaOH will form Na plus and OH minus. So as we can see, these charged compounds already exist in the molecule Na and OH, whereas ionize will means that the molecules or the ions that form were not part of the original molecule. So we would say that ionization, this is a process where the ions or charged species formed are not part of the compound. For example, if we had HNO3 plus H2O, dealing with its with its ionization or hydrolysis, this would form H3O plus and NO3 minus. As you can see, this was not part of our original compound. And that's the difference between the words dissociate and ionize.